Dear student, in last class we learn a cell, the types of cell we learn, primary cell and secondary cell. To understand the characteristic or properties of a cell, you learn two important terms. One is called EMF, electromotive force, and the one is called internal resistance. Dear student, in our last class I clearly explained what is the definition of EMF, electromotive force, as well as what is the meaning of internal resistance. In today's class, we are going to discuss if the cell is connected to external circuit. If cell is connected to external circuit or external resistance, what is the current drawn from this cell? Or we are going to discuss the expression for current drawn from this cell. In other words, current in a simple circuit when a cell is connected to external resistor, or we have to find out the expression for main current in terms of EMF of a cell and internal resistance. Dear student, in last class I provided the diagram like this. And again I consider one beaker arrangement like this. Inside this beaker I provided two electrode. I told one is a positive electrode, it is a positive terminal, and the one is negative electrode, it is called negative terminal. There are two electrodes are taken. One is called a positive electrode and the one is called a negative electrode. We denote it as one is P and the one is N. And this is system containing electrolyte like this, electrolytic solution. This system containing electrolytic solution like this. Again here, this one represent the what? Electrolyte. ಇದನ್ನ ಎಂತ ಕರೀತೇವೆ? Electrolyte. These two are called electrode. One is positive electrode and the one is called negative electrode. In an electrode, inside the electrolyte, I consider 2 points. One point is A and the point is B. ಒಂದನ್ನ A ಅಂತ ಕರೀತೇನೆ, ಇನ್ನೊಂದನ್ನ point B ಅಂತ ಕರೀತೇನೆ. There are 2 points I want to think. One point is taken as, I assume that this particular point is A, this particular point is B. You already know about that. When I want to pass the energy, automatically in a system there will be a formation of ions. One we call it as cation and the one is called anion. He is moving from one electrode to another electrode. Always charge is moving from lower potential, negative terminal to positive terminal in an electrode. Electrons are moving from here to here, or charges are moving from here to here. And again this system is connected to external circuit like this. I assume that external circuit got a resistance is equal to capital R, is connected to external circuit. Dear student, without this external resistor, I can clearly say that whatever potential difference between positive and negative electrode itself is called EMF. Remember, without external circuit, for open circuit, potential difference between P and N itself is called EMF. That's why you learn clearly there for open circuit. For open circuit, keep this point in your mind. For open circuit, that means without external resistor. Without an external resistor, potential difference between positive and negative electrode, that is called V plus and V minus, that we taken as V plus and V minus. Potential difference is V plus and V minus, that itself is called as EMF. That itself is called as EMF if the circuit is open. ನೆನ್ಪಿಡ್ಕೊಳ್ಳಿ, ಈ ಎರಡು ಎಲೆಕ್ಟ್ರೋಡ್ ಅನ್ನ ಒಂದು ವೇಳೆ ಎಕ್ಸ್ಟರ್ನಲ್ ಸರ್ಕ್ಯೂಟ್ ಗೆ ಕನೆಕ್ಟ್ ಮಾಡಿಲ್ಲ ಅಂತ ಆದ್ರೆ potential difference between positive and negative electrode itself is called EMF. EMF is the potential difference between positive and negative electrode of a cell if a cell is open circuited or no current drawn from this cell. ಒಂದು ವೇಳೆ current draw ಆಗಲಿಲ್ಲ ಅಂತ ಆದ್ರೆ. And again by using this we got EMF is equal to V plus V minus. Actually we will get the potential difference negative of minus V minus. It becomes V plus. Here EMF we got V plus V minus. Automatically when I connect the external circuit, this system is equivalent to system like this. I indicate this cell This one is a representation of cell. One is called positive electrode and the one is called negative electrode. Here we got the potential is V plus. Here we got the potential is V minus. This one is connected to an external resistor. This one is a representation of external resistor like this. Its value is equal to R. External resistance R. Again, by connecting the external resistor, circuit become closed now. This one is a closed circuit. This exactly diagram in a circuit format I wrote like this. Idanne exact agi ee tara baradidane. From this cell, current is drawn, that I taken as I. And apart from this, I clearly said, due to the presence of electrolyte in a cell, it will provide the internal resistance. It opposes the flow of charge from negative terminal to positive terminal. That means from B to A. It opposes the flow of charge. There will be an internal resistance that we denote it as R. That internal resistance is provided by the electrolyte. Nature of electrolyte and concentration also. All those things plays important role to get the internal resistance. I clearly explained. Internal resistance depending on a area of the electrode plate, and not only that, it depending on a separation between the electrode, it depending on a concentration, depending on a temperature. Not only that, it depending on a nature of electrolyte what we use. Adar melella depend agi internal resistance change agutte. Ee circuit I consider, and again by considering this part I want to work out for closed circuit now. Now again, next important thing, for closed circuit with external resistor. For closed circuit with external resistor, I can say that here potential difference between the ends of the electrode, potential difference PD across ends of electrode or ends of cell is equal to, there will be a three important term here. One is potential difference across a point P to A. Potential difference across P to A, that is from this particular point to here, potential difference between P to A plus potential difference across again A to B also. Circuit will complete only if electrolyte provide the path for flow of charge. But this electrode or electrolyte, it may oppose the flow of charge, but it will provide the path with certain opposition. Automatically potential difference across A to B, potential difference across A to B, then plus potential difference across again here N to B. Dear student, potential difference across the two ends of a cell is divided into here three major parts. What are the three major parts? Means potential difference across P to A, from this point to this point, potential difference. Next, potential difference across A to B. Andre E point in the E point, it opposes the flow of charge, I already said. Third important thing, potential difference across N to B. By considering this, you have to simplify further. Here, potential difference between P to A is V plus, that I already denoted. Potential difference between N to B is V minus, that also I already defined. Potential difference between A to B, it opposes the flow of charge, I already said, due to the presence of resistance called internal resistance R. According to Ohm's law, here potential difference between these 2 points we call it as I into R. Automatically potential difference across the two ends of a cell, either naduve we denote it as V. That V is equal to, first you have to write potential drop or difference across P to A, that is V plus, Next, potential difference across A to B, illinda illige, that is I into R. R is the internal resistance, it opposes the flow of charge, and illinda illige flow ಆಗ್ತಿರುವ current ಏನು ಕೇಳಿದ್ರೆ I. Automatically you have to take here I into R, but here I indicate negative. In place of plus I taken negative. ಯಾಕೆ ಇಲ್ಲಿ ನೆಗೆಟಿವ್ ತಗೊಂಡಿದ್ದೇನೆ ಕೇಳಿದ್ರೆ, ಸಿಂಪಲ್ ಥಿಂಗ್, ಕ್ಲಿಯರ್ಲಿ ಐ ಸೆಡ್ ಚಾರ್ಜಸ್ ಆರ್ ಮೂವಿಂಗ್ ಫ್ರಮ್ ಬಿ ಟು ಎ, ಅಪೋಸಿಟ್ ಆಗಿ ಚಾರ್ಜ್ ಮೂವ್ ಆಗ್ತಾ ಇದೆ. ಚಾರ್ಜಸ್ ಆರ್ ಮೂವಿಂಗ್ ಫ್ರಮ್ ಬಿ ಟು ಎ, ಅಪೋಸಿಟ್. That's why I taken here minus IR plus automatically potential difference across N to B is nothing but V minus, is already taken. It becomes V minus. It becomes V minus. Rearranging this equation, we got V is equal to V plus V minus I taken together minus I into R. Dear student, from equation 1, you already seen, from equation 1, by using V plus V minus is equal to what here? E itself is called EMF. Therefore, this equation becomes V is equal to, by substituting here, we get V is equal to V plus V minus is equal to EMF. It becomes EMF minus I into R. I call this one as equation number 2. Dear student, remember this, it is called equation number 2. Next important thing, again in the same format, I clearly said V is called potential difference across the ends of a cell. Potential difference across the ends of a cell is V. Across the ends, we provide the resistor is R. Automatically potential difference here, it becomes I into R. Here also it becomes I into R by drawing the current I. Automatically potential difference between the ends of the electrode or ends of the cell becomes I into R, where potential difference between ends of the electrode or ends of the cell is V is equal to I into R. I clearly said V is equal to I into R. Therefore, equation 2 becomes V is equal to E minus IR. In place of V, what I to take? I into R. It becomes I into R is equal to E minus IR. Is equation 2 is converted like this. In place of V, what I taken? I into R is equal to E minus IR. After rearranging this, I into R plus I into small r, it taken to this side. It is equal to EMF. Here I is common in both the term. Automatically I into R plus small r is equal to EMF. In other words, I is equal to EMF divided by R plus R. Remember, where I is the formula for main current, where I is the expression for main current in terms of EMF and internal resistance. Keep one point clearly in your mind. If there is no external resistor, you have to take R is equal to 0. We got the equation for main current drawn from the cell is EMF divided by R plus R, where R is the internal resistance, where capital R is the external resistance, by connecting external resistance to the cell. And again, in case of this, if I consider the short circuit, in a case of short circuit where R value is equal to 0, automatically the current drawn from the cell becomes maximum. The maximum current drawn from the cell becomes EMF divided by R. Remember, if circuit is short circuited, we say that external resistor is equal to 0. The current drawn from the cell becomes maximum. Maximum current drawn from the cell is equal to E divided by R, where small r is the internal resistance. Its value is very small in most of the cases. Is a question. They're going to ask maximum in a competitive exam. What should be the maximum current drawn from the cell if a circuit is short circuited or external resistance R is equal to 0? Dear student, potential drop across the two ends of a cell, that we taken as V is equal to, I already said, I into R. V is equal to I into R. From this we got the value for main current is equal to V is equal to, here main current value is equal to what the value I got? EMF divided by R plus small r into capital R is a formula for potential drop across the two ends or two terminals of the cell. Remember, potential difference between two terminals of the cell when a cell is closed itself is called terminal potential difference. Itself is called terminal potential difference, is also called terminal PD. Terminal PD is the potential difference between two ends of the cell when the cell is closed. Keep this point in your mind. Potential difference between two ends of the cell when the cell is closed, or for closed circuit, whatever potential difference between two ends of the cell or electrode or terminal itself is called terminal potential difference. Again, by using that equation, we can think about two important cases. First case, if I consider for an ideal cell, internal resistance of a cell is equal to 0. Internal resistance of a cell is equal to 0. Potential difference between two terminal we call it as electrode itself is equal to EMF. Keep this point in your mind. Itself is equal to EMF. If I connect the external resistor, automatically V is equal to E divided by R plus R into R, where R is equal to what the value I said, 0 for ideal cell. Remember, by using this formula, we come to know that V is equal to E divided by EMF divided by R plus small r into R. For an ideal cell, internal resistance is equal to 0. E term 0 agatte, automatically these two gets cancelled, we get the answer V is equal to E. Remember, by using terminal potential difference, I can say that for an ideal cell, internal resistance is equal to 0. Automatically, potential difference between two ends or terminals or electrodes is V is equal to EMF itself by considering the simplification. And second important result here, if I consider next important thing, external resistor R is equal to infinity, that we call it as open circuit. If I assume that external resistor R is equal to infinity, that we call it as open circuit, automatically above equation we can write it as, in case of this, here we can write V is equal to EMF divided by R plus small r into R. This we can write it as, divide both numerator and denominator by capital R. This one I can write it here also, divide both numerator and denominator by capital R. We get EMF divided by 1 plus R divided by capital R is a formula for potential difference or terminal potential difference I got. If I assume that R is equal to infinity, this formula becomes EMF divided by 1 plus R divided by infinity. Here R divided by infinity is equal to 0. We come to know that terminal potential difference itself is equal to EMF. Terminal potential difference itself is equal to EMF. Remember, these two are the important important result for terminal potential difference. Dear student, potential difference between two electrode or terminals of a cell itself, V is equal to I into R. Dear student, we already learned the formula for current drawn from the cell, that is E divided by R plus R into, again we got here R. Here terminal potential difference is the potential difference between two ends of a cell when a cell is closed. There are two important cases here. For an ideal cell, internal resistance you have to take it as 0. By considering R is equal to 0 in above equation, after simplification we come to know that terminal potential difference itself is equal to EMF for an ideal cell. Second result, if I consider external resistance is equal to infinity, that circuit we call as open circuit. When a circuit is open circuit, by simplifying above formula again, here V is equal to E into R divided by R plus R. Divide capital R both in numerator and denominator, we come to know EMF divided by 1 plus R divided by capital R. Here capital R itself is equal to infinity. After simplification we get terminal potential difference itself is equal to EMF. These two are the two important results related to terminal potential difference. In general, terminal potential difference is the potential difference between two ends of a cell when a cell is closed. These are the important part for exam. Commonly they're going to ask these two part in exam, mainly in a competitive part like CET, NEET or JEE Main. Thank you.